This lesson covers operations with radical expressions. You've already simplified expressions with nth roots. Now we're going to extend that knowledge again to a little bit to look at radical expressions. We'll add, subtract, multiply, and divide them, and we'll simplify them. We'll do things like rationalizing a denominator because we never want to have a radical expression in the denominator of a fraction. We'll use like radical expressions. We'll add and subtract them. We'll work with conjugates, something we've discussed briefly before. Let's look at the first property. A product property says that for any real numbers a and b, and for any integer n greater than 1, the nth root of ab has to equal the nth root of a times the nth root of b, if n is even, and a and b are both non-negative, or if n is odd. Okay, so for example, the square root of 2 times the square root of 8 equals the square root of 16, or 4. The cube root of 3 times the cube root of 9 has to equal the cube root of 27. Okay, note you've got to have the index numbers the same here to be able to separate those products under the radicand. Let's look at an example. Simplify this expression. We're looking at a square root. Under the radicand we see 5 squared times a squared squared times b to the 4th squared times b. We're separating these into square factors, aren't we? So we can use the product property of radicals to separate them under different radical signs and simplify. Let's look at one more example. Since we have a cube root, we're separating this into cube factors. 125 is 5 cubed. M to the 30th is m to the 10th cubed. Remember our exponent rules. P to the 20th is p to the 6th cubed times p squared. We're factoring it into even cube factors. Then we use the property of radicals to separate those under different radical signs and simplify. So this is our final answer. All right, now you try.